Okay, let's talk about precipitation reaction. A precipitation reaction is a reaction in which aqueous ions in separate solutions are mixed together to form an ionic compound that settles out of solution as a precipitate. Remember, precipitate was a sign of a chemical reaction. Remember, it's a solid thing. So back in the day, when we mixed Red Bull and milk together, it created a precipitate. It's a solid. It's not like a rock solid, but it does create those chunky solid bits. A precipitate is what we call an insoluble product. So here we have a prefix in, meaning that it does not dissolve in water. It's not soluble, okay? So you got to remember that these words go together. When you see the word precipitate, you're always going to think solid, okay, because that's the definition, and it's insoluble, okay, meaning that it cannot dissolve in water. It always see chunky solid parts, okay? So let's recap some vocabulary words. So the question is, does it dissolve in water? If the answer is no, then we say it is insoluble. Remember the prefix in meaning not soluble. It does not dissolve, right? So here it does not dissolve. It forms a precipitate, which is a solid thing, okay? If it does dissolve in water, then we say it is soluble. It will dissolve in water, and therefore it is aqueous, okay? And aqueous, remember, meaning that it's in a homogeneous mixture. It looks the same all the way across. You can't tell there's a lot of different things in it, even though there are. So it all looks the same. That's aqueous, okay? So we're going to use what we call a reference chart of solubility rules to determine which compounds will produce a solid and which one will produce an aqueous substance, okay? So which ones are insoluble and which ones are soluble. So they're called the solubility rules, okay? So let's take a look at this chart. So here's this chart right here, okay? You do not have to memorize it. This is on the back of your periodic table. So if you flip to the back of your booklet and on the inside cover there, back cover, you will see this chart, okay? So let's make some little side notes of how to read this chart, okay? So here's your solubility rules, okay? Remember that soluble means it's an aqueous substance, okay? Something is aqueous. Okay, so this whole list of little compounds here, if you see any of these compounds inside or inside a larger compound, you will have an aqueous solution, okay? Now, it does have common exceptions, okay? So it's saying that all of these right here, all of these are soluble. They're going to be aqueous unless, okay, so you're going to be like, unless they are attached to one of these things down here, okay? So here we have these common exceptions down here. If you have a compound attached to these things down here, then we say that it will be solid, okay? It's going to create a precipitate. Okay, so Ag is silver, Pb is lead. Then down here you have strontium, barium, and lead. Okay, but if you see any of your up here substances attached to one of these things down here, then you know it's going to create a solid. It will not be aqueous. Okay, on the other hand, the bottom part of this chart here is the opposite. Here you see the prefix in, meaning that any of these compounds, if you see a compound with any of these substances, it will be a solid, because insoluble means it creates a precipitate. Okay, so all of these substances here will create a solid, except, so it does have exceptions here. So you're thinking unless it's attached to one of these things over here, okay? NH4 is ammonium, Okay, and then you have these exceptions down here, and alkali metal cations. So the question is, what are alkali metal cations? Alkali metal cations is the first column of your periodic table. Okay, it consists of lithium, right? Sodium, potassium, rubidium, and cesium, and also francium. They are always going to be aqueous. Okay? Always going to be aqueous. So we're going to use this chart. I know it looks a little confusing now, but once we go through the examples, then hopefully you'll get a better idea on how to use the chart. Okay, so here's our first example. We have ammonium sulfide here, cadmium nitrate here, and it's going to create two products. So we're going to look at these products. Okay, so these products have empty slots here and here, and we're going to determine, are we going to put an S for solid? Does it create a precipitate? Or are we going to put AQ for aqueous because it all dissolves? Okay, so we're going to use our chart to determine what goes with what. Okay, so now you're going to look at NH4 and NO3, and you're going to find one of these things on the chart. And both of these things are actually on the chart. So let's look at our chart. Where do we see NH4 and NO3? There's NH4 here, and NO3 is also here. So look at the chart. It's under the soluble compounds here. Okay, so under the soluble compounds, it means that it will be aqueous. Okay, you look across, and there are no exceptions. So it's always going to be aqueous. So if you look here, you're going to write that this is aqueous. Okay. Next, you're going to look at CDS. Okay, so you're going to either look for cadmium or you're going to look for sulfur. Okay, usually it's always the second one in the compound that is going to be on the chart. So if you look on the chart here, cadmium is not here, but we do see sulfur. Sulfur is where? Look on this chart. Look. It's all the way down here. So you look at this chart and you say, okay, sulfur is always a solid, always insoluble, unless it's with one of these things down here. So we have to double check. Is it attached to an NH4? Is it attached to an alkali metal cation? Is it attached to a calcium, strontium, or barium? Okay, luckily the compound is right here, so we can take a look. Okay, there is no NH4, so not here. Cadmium is not an alkali metal cation, so it's not here. And cadmium CD is not Ca, it's not Sr, it's not Ba. So it's not part of the exception, so that means it will become a solid. So if it's a solid, you're going to put an S here. If you write an S, you say, yes, there is a precipitate. What is the precipitate? You write the entire compound, CDS. CDS is our solid precipitate. So PPT means precipitate. Okay, so that's what it's asking right here. Okay, so let's do another example, number 1. Okay, does a precipitate form? So we're going to look at these compounds right here. HCCl2, K2S, it's going to create two compounds right here. So we are going to look generally at the second part of the compound on the chart. So it has a letter S. So we're going to look for the letter S. S is here on the chart. It is under the insoluble compound. So this is how you would say it. Sulfur is always insoluble, or you can say sulfur is always a solid unless it's attached to any of these things that are next to it. So you got to look. Okay, the sulfur is attached to an Hg. It's a mercury. So you're going to look and be like, okay, is mercury, Hg, any part of these exceptions? And the answer is no, it's not. And because it's not part of the exception, so you're going to go back here and you're going to say it is a solid. Okay? Next, you're going to look at this compound, potassium chloride, and you generally look at the second part here, Cl. Okay, so you're going to look, where is chlorine on this chart? Chlorine is here on the chart. Okay, chlorine is always aqueous. It's always soluble unless it's attached to one of these, a silver or a lead. So is the chlorine attached to a silver or a lead? The answer is no. So that means it will be aqueous. Okay, another thing is that here, if you look at potassium and you look at this section right here, potassium is an alkali metal, and alkali metals are always aqueous. Okay? Okay, so let's look at the next example. Okay, here you have your two compounds, and then we have a copper phosphate, and we have an ammonium chloride here. So let's look at this PO4. Let's find this on our chart. So PO4, find it on your chart. PO4, it's right here. So you say phosphate is always a solid unless it's with one of these things. Okay, so you're going to look, is phosphate with an ammonium or an alkali metal? So you go back and be like, okay, is this an ammonium or alkali metal? The answer is, so you look here, here are your alkali metals. Nope. And so that means that this will be a solid. So you put S for solid. Okay. Next, you have NH4Cl. Okay, NH4Cl. So you're going to find NH4 or Cl. Okay. NH4 is here and Cl is here. They're both under aqueous. So we say that these are always aqueous unless it's attached to, okay, there's no exceptions there. And over here, is it attached to a silver or a lead? The answer is no. So that means it's always going to be aqueous. And oops, I forgot to fill out the rest of this chart here. So if you have the letter S, you're always going to say yes. Okay, and whichever compound is the letter S, that's the one you're going to write in your precipitate. So over here, we're going to write HGS because that was our solid. And over here, we're going to write our copper phosphate like that. All right, let's do another example. Here we have aluminum nitrate, and here we have sodium phosphate. All right, so you're going to look at this NO3 here. All right, so let's find it. NO3 is, where is it? Right here. So you say NO3 is always aqueous unless it's attached to, there are no exceptions. So that means NO3 is always aqueous. So you're going to look over here and you're going to write AQ for aqueous. All right, next you have a sodium phosphate. So you can look for PO4. PO4 is right here. So you say phosphate is always a solid. It's always insoluble unless it's attached to one of these things. So you check, is it attached to an NH4 or an alkali metal? Remember, your alkali metals are right here. So you look and you're like, Na is right here. Here's Na. So you know Na is an alkali metal. So phosphate is always a solid unless it's attached to sodium. That means it's the exact opposite. So it's going to become aqueous. So you're going to look over here and you're going to say, hey, this is aqueous here. So here you have no solid. So the answer is no. I don't have any solids. So over here you can just put an X because there is no precipitate. We do not have a solid compound. Okay, our last example here, we have a PbCl2 and a NaNO3. All right, so let's look at the chlorine. So let's look here. Find chlorine on your chart. It's this one right here. So chlorine is always aqueous, always soluble, unless it's attached to one of these things. So if it's attached to one of these things, then it becomes the opposite. It will become solid. So you're going to check, is it attached to a silver or a lead? So you go back. Yes, it's attached to a lead. So if you look back at your chart, it's not going to be aqueous anymore. It's attached to an exception, so it becomes the opposite. It will become a solid now. So you're going to go back and put the letter S here. Next, you have NaNO3. There are two ways to solve this one. NO3 is right here. NO3 is always aqueous, always soluble, and it has no exception, so it means it's always aqueous. If you look here, sodium is on this box right here. Sodium is always aqueous, so you're going to put AQ right here. If you have the letter S for solid, then you're going to circle yes, and you're going to write this entire compound off to the side here, which is PbCl2, like this. All right, so let's do a quick recap. Okay, so you're going to use your chart to determine whether compounds are soluble or insoluble, meaning if it's soluble, it's always going to be aqueous. Okay, so this entire section here is always aqueous unless, so here are the exceptions, unless it's attached to one of these things down here. Okay, so bromine has exceptions, chlorine has exceptions, iodine has exceptions, and sulfate has exceptions. If it's attached to one of the exception, it becomes the exact opposite and it becomes a solid. Okay, then you have the bottom of the chart here. You have the insoluble compounds, meaning that you will create a solid compound. So all of these are always solid unless it's with one of these exceptions, right? So all of these have exceptions. So you gotta look at the exceptions, okay? All of them have NH4. So NH4, right? And all of them say alkali metal cations. So anytime you see an alkali metal or NH4, it will always be aqueous. It's always going to make it opposite. Okay, hydroxide and sulfur down here have more exceptions. So if you see it attached to any of these or sulfur with any of these, then you are going to become the opposite, which is aqueous. Okay, so you're going to use this chart. You don't have to memorize it to determine which compounds are aqueous and which compounds are solid on the next practice page. Good luck.